Welcome back to Arts Learning. In this video, we'll be going over explosions and recoil, as well as 2D collisions and how to solve those. Okay? The 2D collisions do get very intense, so I would recommend to stay for those, if not for explosions. Alright. The reason I wanted to give explosions its own separate, section was because it's a bit hard of an idea to understand. But you have to keep in mind, right? If you had a gun here, the second you fire the gun, the bullet is still inside the gun, right? So what happens once you fire the gun? The bullet pushes forward, right? At a crazy speed. It's very high speed. That's why it's able to pierce through people's, bodies, right? So what happens to the gun if you follow our principle of conservation of momentum? The gun is also going to recoil, right? It's also going to move back and it's going to have the same momentum. But the thing is, the bullet has a way higher velocity, right? So the gun here, since it has a higher mass, it's going to have a lower velocity. So same momentum, but the thing is, one V is big here, but one M is big here. So that's why they, has a fast velocity or a slow velocity. Because if it's heavy, then you can understand how. This is heavy and this should be slow, right? The velocity should be lower to keep it match with this velocity here, which the gun got. Alright, so let's just look at an example question. A 4 kg rifle fires a 0.01 kg bullet at 400 meters per second. Find the rifle's recoil. Okay, so mass 1 here, which is 4 kgs, times what? Well, its initial momentum for the mass is 0, right? 0 plus what? 0.01. And the same thing, initial momentum is 0, right? Because they're both stuck inside the thing. So the initial momentum is 0, which means the final momentum has to be 0. That's why I'm going to set them equal here. So 0 is equal to 4 times velocity initial. Velocity 1, so velocity of, maybe I should just put this in velocity of rifle, okay? Plus 0.01 times the velocity of the bullet. Now what am I going to do? So for VR, the rifle's recoil we don't know yet. We were trying to find that, right? But the bullet speed, we know that. That's 400 meters per second. So 0 is equal to 4 VR plus 0.01 times 400. So 0 is equal to 4 velocity of rifle, or the recoil, plus 4. So VR is equal to, 4 in VR is equal to negative 4. And VR is equal to negative 1 meter per second. So what does this mean? This means the gun goes backward, right? If you consider the direction of the bullet as a positive direction, then if the gun is going backward, that's a negative direction, right? So that makes sense. That's pretty intuitive, okay? As that's because the gun is 400 times heavier, so it makes sense. The gun wouldn't be heavy by itself, but compared to the bullet, right? Okay, so let's try these problems now. A 60 kg astronaut at rest throws a 2 kg wrench at 5 meters per second. Okay, so initial momentum is 0, so its final momentum is going to be that as well. A 2 kg, so 2 kg wrench at 5 meters per second, right? And let's just say that's to the right. If that's to the right, and that's why it makes sense, right? They gave us a positive velocity, so I would assume it's to the right. Then I would give plus 60 times velocity final. And this velocity should be negative, right? Accordingly. So negative 10 Newton seconds is equal to 60 velocity times the velocity final. Or velocity final is equal to negative 1/6 meter per second. That's a recoil speed, okay? So it's pretty intuitive there. Not too much to think about. A firecracker at rest splits into a 0.3 kg piece at 8 meters per second right, and a piece going left at 4 meters per second. Find that piece's mass. If one part of the piece is going leftward, that's negative, right? And if one part of the piece is going forward, that's positive or rightward. So we're going to construct the equation accordingly. 0.3 times 8, which I'll give a positive 8 because it's going to the right, and then plus what? Well, we don't know the other piece's mass, right? We know one piece has a mass of 0.3, but the other one we don't know. So we'll just put an m there, times the other piece is going -4 to the left, right? And that has to be equal to 0 because before the firecracker splits, it was at rest, right? Which means the momentum was 0. So what is this going to be then? This is going to be 4m is equal to 8 times 0.3. Alright? Or if you're to find this, it would be 8 times 0.3 divided by 4, about 0.6. Okay, 0.6 kgs. Which makes sense, right? If this is double here, if the velocity is double of this velocity, then this mass must be double to compensate for that, right? Okay, so now 2 carts, 1 kg and 3 kg, are pushed apart by a spring from rest. So they were initially just like this, okay, attached to each to the spring, but now they're not. The 1 kg cart leaves at 6 meters per second. Find the 3 kg cart's speed. Okay, so 1 kg times 6 meters per second. So that's positive, right? Because it's going at 6 in the rightward direction. And then 1. That plus 3 kg times velocity final is equal to 0. So 3 velocity final is equal to -6. Or Vf is equal to -2 meters per second. Right? Which means, it's going backward. So it makes sense, right? Because it's going the other way. Alright, so now let's look at two-dimensional collisions, okay? The other facet of this. So, two-dimensional collisions, that often happens, right? Sometimes cars hit each other at a two-dimensional angle because they have an x momentum and a y momentum, right? Because, they're just swerving on the road. So 2D methods would come in handy here. So Px before has to be equal to Px after. Makes sense, right? You're just splitting this into vectors here. Py before has to be equal to Py after. Here you just have to split in components sometimes. And then, these are just the regular vector formulas. Okay? You cannot add momenta that point in different directions. You have to always break them into different components first. Alright, so now let's try an inelastic 2D collision. A 1000 kg car east at 20 meters per second. Okay, it's going east at 20 meters per second and hits to a 1500 kg car north at 15 meters per second. Okay, so 1000 times 20 here. What's that going to be? That's our momentum in the x direction, right? 1000 times 20. So the thing that's happening here is this car, right? Think about it visually. One car is going east, okay? So this direction, rightward. And one car, so I don't really know how to draw the top view of a car, but it's good enough, right? It's going to the north here. So then this car bashes into this car, and then they move as a combined object. That's why it's perfectly inelastic. So I didn't include that, but imagine it's perfectly inelastic, okay? So Px should be what? Well, this car is only providing a vertical momentum, right? Because it only has the northward or upward momentum here. The x component the x momentum is coming from Px, which is 1000 times 20, or 20,000 Newton seconds. Okay? Now, what about Py? Well, this car has no y component, right? That component is coming from this car that's going northward, which is going to be about, what is the mass of this car? 1500 times 15. or 22,500 Newton seconds to the north. Okay? So then what's that? How are we going to denote that? That's just going to be, so before we do anything here, we need to find out the total, how do I say this, the total momentum at the end, right? Because this is just the initial momentum in the x direction and in the y direction. We know this is going to be conserved, but then how are we going to denote that in terms of velocity? So what we're going to do is, because we know this is combined mass, right? Perfectly inelastic collision. You remember how it's combined at the end? They break together. I mean, they break and then they mush together, right? They stick together. That's what perfectly inelastic collisions do. So it's going to be here. What's it going to be? It's going to be the combined mass, which is 1,000 plus 1,500. All right? Or 2,500 kgs. And then how are we going to denote this? Well, this 2,500 kgs has two components, right? An x component and a y component, because one is going this way, one is going this way, and then the others, they just, split. I mean, they don't split, but they crash, and then they move together in this direction. So we know that the velocity final here, we don't need to know the velocity final, but what do we know? We know that the momentum in the x direction and the y direction will stay the same, right? So we know that the entire car, because now it's perfectly inelastic, right? Now it's combined, it's going to still contain that momentum x of 20,000 Newton seconds. So momentum is equal to mass times velocity, right? If you want to find the momentum x, that's just momentum x is equal to mass times velocity x. So velocity x would be equal to momentum x, which is 20,000, divided by total mass, which is now 2,500, right? It's moving as a unit. So the 20,000 divided by 2,500, thousands cancel out. There's two zeros cancel out. And it becomes 200 divided by 25. Or in other words, 8 meters per second. Okay? And then what happens? We need to look at velocity y as well, right? So velocity y here, similar, right? Mass times velocity y is equal to momentum in the y direction. So velocity y is equal to momentum y divided by total mass. Velocity y is equal to momentum y. What do we know that to be? That's 22,500, right? So 22,500 divided by total mass, which is 2,500, right? So these two zeros cancel out. 225 divided by 25. We know that's going to be 9, right? So our velocity y is 9. Now velocity x is 8. So what do we do after this? Well, we just find our velocity final, right? How do we do that? Imagine that they're both on a graph, right, as vectors. So you can see on this graph here, what do they look like? They look like vectors, right? And how do you find the magnitude of a vector, which is your actual magnitude of the total vector, right? That's going to be, if you have an x here, right, x component, and if you have a y component here, then you know, using the Pythagorean theorem, that's just going to be, this vector is going to be the squared of both of these, right? So this vector, the total magnitude of this vector squared, is equal to velocity y squared plus velocity x squared, right? So 9 squared plus 8 squared, or 81 plus 64, which is going to be 145, right? And then you're going to take the square root of that, because this is magnitude squared, right? So then the square root of that is going to be about 12.04 meters per second. Okay, that's your vector magnitude. All right. Now, how do you find the angle here? What's the angle above horizontal? So then how are we going to find that? We're going to do the same arctangent formula, right? Theta here is going to be equal to the arctangent of velocity y and over velocity x. So theta is equal to the arctangent of 9 over 8, or approximately 48.4 degrees. Okay. Be careful with the arctangent, right? You can get an angle in the other quadrant, but you can still get the same angle if you use that. So even if you had a car going in this direction, you'd still get 48.4, even though this is actually like 48.4 plus 180. But you don't need to worry about that, okay? Now for elastic masses, there's two equal masses, but if one is at rest, then they separate it exactly 90 degrees to each other, okay? So what that means here is, if the two paths are not 90 degrees apart, the collision was not perfectly elastic. And way to explain that, so that would be, if there's two equal masses and one is at rest. So if a car was going here, this way, right? And then same car here, but instead of, this car moving, it's staying stationary, then if this car is hitting here, what's going to happen? This car is going to move in this direction if it's perfectly elastic, all right? So you don't need to think about that a lot, okay? That's not too relevant, but just keep it in your mind. Now let's look at one of the hardest questions I could come up with for momentum, okay? A 0.02 kg bullet flies east at 500 meters per second and embeds in a 4 kg block. That block then hits and sticks to a 6 kg block going north at 3 meters per second. Okay, so it might seem a bit scary, but it's not that hard, right? We need to find what the final velocity is, magnitude of the final velocity, and the theta. Okay, what the degrees are. So first we'd find what? The momentum of the block, right? The momentum of the bullet, sorry, because that's going to embed in the block. So 0.02 kgs times 500 is equal to what? So this plus 4 kg times 0, right? Because the 4 kg block doesn't have any velocity. It's going to be equal to, since it's a perfectly inelastic collision, because it embeds itself in the block, right? Both the masses are going to be combined. 4 plus 0.02 times velocity final. So 500 times 0.02 is 10, right? 10, this is 0, is equal to 4.02 v. V is equal to 10 divided by 4.02, or 2.49 meter per second. And what's the direction of this? To the east, right? Because it's going to the east. Makes sense. The bullet's flying at the east. It's just going to continue in the east. Pretty intuitive. But then this block goes and sticks to a 6 kg block going north at 3 meters per second. So imagine this block, right? It's going like this. Now at 2.49 meters per second. And its mass is 4.02 kgs. And one other block is going northward at 3 meters per second, but its mass is 6 kgs. Very similar to the car problem we saw, right? So momentum in the x direction, this entire momentum here, so px, which should be, let's see, just 0.02 times 500, right? Because that's just what we have here. So our px would be 10, because, if you didn't understand what I said, the initial momentum here is px, right? Because it's only going in the eastward direction, the momentum of the bullet. So I can just take that, because this is just 0. So the initial momentum comes from just the bullet. And we notice that's going to be 10. So px is 10. Py is the momentum of the block going northward, right? Which is 6 times 3, or 18 Newton seconds. Now, I'm going to highlight both of these blocks. And what does this mean? So we have px equal 10 and we have py is equal to 18, right? But these are the momentum. How are we going to find the velocity here? The velocity, so px is just equal to mass total, right? Mass total times vx. Since the blocks, we can assume the blocks mush together, right? It's like a perfectly inelastic collision. Then we know that the blocks are going to have the same mass. The total same mass. So px, which should still remain 10, because px initial is px final, is equal to mass, right? So the total mass here is what? It's 4.02 plus 6, right? Because it's going in that direction. And it's going to add a 6 because now it's going to take up this block as well. And then that times the velocity x. So 10 divided by 10.02 is going to give you your velocity x, which should be about, let's see, 0.998 meter per second, all right? And then velocity y is going to be, similarly, py is equal to mass total times velocity y, or py is 18 divided by same total mass here, 10.02. It's going to give you your velocity y, which is about 1.796. Okay? And then if you want to find the total magnitude here, so if you know velocity y, let me just bring these here. If you know velocity x, right? So how are we going to find the total magnitude? We're just going to use the, the good old magnitude formula here. So magnitude of the total velocity, or the final velocity itself, would just be square root of the y velocity, which is 1.796 squared, right? We're going to square these both, plus 0.998 squared. Okay, so what's this going to give us? This is going to give us roughly around 2.05 meter per second. And if you do arctan of the velocity y over the velocity x, you'll get 60.9 degrees. So like about this much, okay? Now what? Well, that's it, right? That's just the hardest. I don't think it can get harder than that for simple momentum, at least. Maybe if you get to AP Physics C and it's like more calculus-based momentum, but we'll see about that later. You just need to worry about this for now, okay? So from here on, we've finished momentum and we'll be moving on to centripetal acceleration, as well as Coulomb's law and electrical fields, okay? So do stay tuned for that. And make sure to give me a like and subscribe if I helped you, so I can continue helping you and also help others.